We talk about it as body motion, which has a lot to do with body mechanics and physics. Can be somewhat complicated because everything's not real cut and dry, because you got to look at different forces on the body. You have to look at internal, external, and so forth, and we're going to talk about that. Body motion is produced by muscle contractions. In this case, we talked about the bag of bones earlier and how you can't move without skeletal muscles. Motion cannot occur without a force, and ultimately that's what we're talking about, generating force. There are two basic types of motions. You got linear motion versus angular motion. Linear motion, or translatory, is the movement along a straight line. So like if you do a bench press, you have a linear motion. It's just a straight line when I'm talking about pushing that weight from this point to that point. Displacement refers to a change in location of an object from its original point of reference. Distance refers to the actual sum length of measurement traveled, so you have a certain distance going along actually. And then linear displacement is distance that a system moves in a straight line. So those are the different types of motion and how they're displaced and so forth. Angular motion, or rotary motion, which would be in terms of like an arm curl. It's a curved path of motion as opposed to linear is a straight path. So you do an arm curl, you got angular, it's a curving path. It's not just a straight line like a bench press. And so when we talk about displacement with an angular motion, you talk about angular displacement, refers to the change in location of the rotating body. Okay? The forces that cause motion apply Newton's three laws of motion: inertia, acceleration, and our action-reaction principles. A law of inertia is a body in motion tends to remain in motion at the same speed in a straight line unless acted on by a force. A body at rest tends to remain at rest unless acted on by a force. In this case, we talk about there are forces that we're going to talk about, and gravity would be one of them. If we push something, it is not going to continue to go in motion indefinitely because gravity is pulling it down, which causes frictions and will slow it down. Law of acceleration is a body is acted on by a force. Its resulting change in momentum takes place in the direction in which the force is applied. Obviously, we're going to push something that's going to go in that direction. It's proportional to the force causing it, so the harder we apply force, it's going to go faster, and inversely proportional to its mass. So the heavier it is, it's going to be harder to make it move, in other words. Action-reaction, for every action there is an equal and opposite reaction. Okay? If one body exerts a force on another body, the second body will exact an equal and opposite force on the first body, but in the opposite direction. Okay? An illustration of Newton's third law in this picture is in equilibrium, the gravitational force and the elastic force of the spring are opposingly direct and equal in magnitude. Okay? So we got gravitational forces coming down, and the force of the spring is coming up and is holding this in position right there. Force is a push or pull exerted by an object on another to affect motion or shape. Without forces acting on an object, there is no motion. Force is the product of mass times acceleration. The mass of a body segment or the entire body times the speed of acceleration determines the force. So a lot of times, we use the example of, and you see people bench pressing, for example. And you'll see a lot of times people bouncing the bar off their chest. Well, if you think about it, they are having a little bit of a catapulting off their sternum. All right? There is a external force driving a bar off of their chest. Okay? And so they can get away with some momentum in that case. But if you use the squat as an example, where the only thing that as you descend that stops you from going any further to then go back up in the squat motion is your own body, your muscles, right? Not a structural component like the sternum, okay? So when people go fast on their descent on a squat and they have that force going, accelerating a certain amount of mass, say it weighs 300 pounds, for example, and they're going, accelerating a certain amount of speed, that has greater force if they go really, really fast and have to stop it when they hit their desired depth to then come back up. So we can use physics as an example of how going faster, or a person who might say that I'm not lifting heavy, so that's why I'm going fast. Well, I can say to them, well, even if you're not lifting a lot of mass, by you going fast, you're putting a lot of force on your joints. So that's why we want people to be slow and controlled in that case, especially on the negative phase or the eccentric phase, which we'll talk about later. But there are three types of forces: the external force, internal force, and gravitational force. External force is a push or pull in the body that comes from a source outside of the body. Okay, so if somebody is going to come and push you and you have to stabilize and try not to fall over. Gravity is the attraction of the Earth's mass to another mass in terms of that external force. Constant external force on the body. There's a constant external force pulling us down. And we measure the weight of an object and the pull of gravity on the object's mass with the acceleration of 9.8 meters per second squared, or 32.2 feet per second squared, in the absence of any resistance. So we see that weight equals mass times gravity. And that's your formula for that. So we actually know that the actual gravity is a force. And that's what we talked about earlier at the inertia. I mean, we know if we push an object, and in this case, there is something that's going to keep it from continuing to go into motion. That would be gravity in this case. The first force to consider, a potential force acting on a body segment. Examples of external forces are wind, which you got push. So you got a person who's running outside in the wind into a headwind. That's going to be a force on their body. It's going to affect their output. Water, which is it's why we use water training as an example of force on the body. Other people. So if you could be doing resistance with each other. You're doing towel pulls. You'll see bodybuilders do that backstage at a bodybuilding show to warm their lat muscles up and things like that. Other objects, push off the floor, or push off floor on the feet, the push of a weight on the leg. Things like that. Internal force is really ultimately what we do with weight training. Forces that act on the structure of the body and arise from the body's own structures. When you're firing off muscles, the pull of the biceps on the radius, there's a force going on when you do an arm pull, or arm pull-ament, or arm curl-ament. The ligaments are the pull of the ligament on a bone. There's actual forces going on right there. The tendons, obviously, when we talk about that, when we talked about earlier, the pull of the biceps breaking on the radius, well, that's via a tendon. So there's a lot of force on the insertion aspect of that tendon. They are essential for initiation of movement. You cannot have movement without forces. Internal forces also control or counteract movement produced by external forces, as well as counteracting other internal forces. So, if somebody pushes you and you react internally to stabilize yourself, you'll see that in sports a lot. Gravity force, the force of gravity can be fully described by point of application, action line, direction, orientation, and magnitude of the gravity. The force of gravity's point of application is the center of mass or center of gravity of an object. Be familiar with that. The point at which all the mass of the object appear to be concentrated, and every object can be considered to have a single center of mass. Okay, so you can only have one center of mass, and so that's going to change depending on what position you're in, what exercises you're doing, things of that nature. Although the direction and orientation of most forces vary from the source of the force, the direction of the force of gravity acting on an object is always vertically downward toward the center of the earth. Okay, so gravity is always pulling down. It doesn't pull side to side, it always pulls down. That never changes. Even though our center of gravity can change and center of mass can change depending on the structure or the exercise we're performing, it does not affect the center of gravity in terms of the direction of gravity.